Hello, I'm Vince King, Service Business Manager with McElroy Manufacturing. Today I'm going to utilize the outdoor classroom of McElroy University and demonstrate the proper use of a TracStar 500 Series 3 fusion machine. Now the TracStar 500 Series 3 has some unique features. For example, hydraulic clamping comes standard on this machine. In addition to that, we have hydraulic indexing and pivoting of our facer and our heater. Today I'm going to fuse 12-inch IPS DR17 pipe. And I will be fusing this pipe in accordance with the standards outlined in ASTM F2620. This is the widely accepted standard for fusing polyethylene pipe in the United States. This machine is also capable of fusing to other standards that are used throughout the world. So please be sure that you understand the required standard for your region before you begin fusing pipe.
Make sure you have read the operator's manual for the McElroy T500 Series 3 fusion machine, and then inspect the machine you will be using to make sure it is in proper working order and as clean as possible. It is also a good idea to make sure you have the correct size of inserts for the pipe you will be fusing. Now it is time to clean our pipe. Use a clean, dry, lint-free cloth to clean the fusion area. We want to make sure we get rid of anything that can contaminate the fusion area of the pipe, which would contaminate the fusion both inside and out. With the pipe as level as possible, we want to feed it into the machine with about 1.25 inches extending past the inside jaw of our fusion machine. This will allow enough pipe to achieve a complete face-off. Once the pipe is set into position, close the upper jaws and use the hydraulic clamping system to tighten the jaws around the pipe. This applies enough pressure to hold the pipe securely with the aid of the serrated inserts. We need to get our heater up to temperature. Flip the throttle into high idle and then turn on the heater. Pivot the facer into position. Make sure the pipe ends are not touching the facer before turning it on. Shift the pressure selector valve to facing. Shift the carriage control valve to close, and then slowly move the pipe ends against the facer. Control the pressure with the top pressure reducing valve. We want to face with minimal pressure. Apply only enough pressure to allow the blades to shave ribbons of material from the pipe ends. If the facer begins to struggle, lower the pressure immediately. Face all the way to the mechanical stops. This will square up the facer, ensuring the best possible face-off. With the jaws still against the stops, shift the carriage control valve to neutral. Allow the facer blades to make a few more rotations and then turn the facer off. You may open the carriage and remove the facer. Now, inspect the pipe ends to ensure at least one full ribbon of material has been removed. Thoroughly clean the fusion area by removing all shavings and ribbons of material. Bring the pipe ends together to check for proper alignment. If misalignment is less than 10% of the wall thickness, then proceed to the next step of the fusion process. If misalignment is greater than 10% of the wall thickness, then you can make changes to the alignment by adjusting the knobs located atop of the inner hydraulic clamping cylinders. If you need to make adjustments, you must reface the pipe ends. Pivot the heater out of the heater bag frame so we can have access to it. Now wipe down both sides of the heater using a clean, dry, non-synthetic, lint-free towel. Use a pyrometer to check each side of the heater where the pipe will contact it. ASTM specifies that the heater surface temperature be between 400 and 450 degrees Fahrenheit. Just a quick note, there is a thermometer on the heater. It tells the internal temperature of the heater and is only an indication that the heater is hot. Pivot the heater the rest of the way into the carriage. To begin the heat soak, bring the pipe ends against the heater and ensure the entire radius of the pipe is in contact with both faces of the heater. We immediately drop the pressure to drag or below by shifting the pressure selector valve to the middle position. Wait until the gauge or the data logger shows that the pressure has dropped all the way down to drag. Give it an extra few moments and then shift the carriage control valve into neutral. This is the beginning of the heat soak. It is crucial that no pressure is applied between the pipe and the heater. Just watch the pipe and verify that it stays in contact with the heater. Any pressure will cause the heat to not properly penetrate the pipe. For 12-inch IPS pipe, the heat soak will be complete when we have reached a minimum of 1/4 inch bead width. For this pipe size, ASTM specifies 15 seconds maximum to open the carriage, remove the heater, and to close the carriage to make the fusion. Remember that this is a maximum. The faster we can safely remove the heater and bring the pipe ends together, the better. Leave the carriage control valve in the closed position to allow the joint to cool under pressure. The joint is now in the cooling process, and it is just a matter of waiting for the cool cycle to complete before we remove the pipe. Cool time is the wall thickness in inches times 11 minutes. To figure out the wall thickness, we will take the outer diameter of the pipe and divide it by the dimension ratio, or DR. You can look up the outer diameter dimensions of most pipe sizes in the back of our catalog. Our pipe is 12-inch IPS DR17, which has an outer diameter of 12.75 inches. So we will take 12.75 inches and divide it by 17, which gives us a wall thickness of 0.75 inches. To calculate our cool time, we will take our wall thickness of 0.75 inches and multiply it by 11 minutes. The cool time for 12-inch IPS DR17 pipe will be 8.25 minutes, which works out to be 8 minutes and 15 seconds. Once the cooling cycle has completed, shift the carriage control valve to neutral, unclamp the jaws, open the carriage, and inspect the fusion. A good fusion will have a double rollback bead with a uniform appearance on each side. Check for any debris or pitting in the joint, and if all is well, then move on to the next joint. If you notice anything out of the ordinary, cut the joint out and start over.
I hope this video gives you a better understanding of how to operate a TracStar 500 Series 3 fusion machine. Be sure to check out McElroy's many other operation videos to help with all your fusion needs. Go to www.mcelroy.com/fusion to find additional information, including charts and other reference materials.